Good morning. Today I thought I might have a look at this Kriesler radio. It's an 1120 model. This was first produced in 1948 and I think it ran to about 51, and over that time it had various modifications, probably more to do with availability of parts more than technical advances. So colloquially these are called a plum pudding, and of course plum puddings are typically British. So we in the Brits and other countries too, I assume, have these as the finishing course for Christmas lunch or Christmas dinner. I'd have to be honest and say I'm not sure how much it looks like a plum pudding, I guess. You judge for yourself. Yeah, maybe. Now this particular set, I got this from the club auction. I don't think I paid a lot for it. It looks like somebody's already had a go at it once before, and perhaps a long time ago. There's a fair bit of dust still in the crevices. Now I've got the circuit diagram there. This is a shortwave unit, so that'll be volume. It's got an on-off switch, volume. That's another switch. That'll be tone, I suppose. That'll be the tuner, there you go, and this would be the shortwave, I would imagine. As I said, somebody's already had a go at it. It's got a new plug in it. So I'm going to spin it over and we'll take the bottom off and see what's inside. Typical Kriesler construction of the time, it's just got a big Bakelite base on the bottom. And that reveals all the components inside. Nice and neat to work on these. Now this is from 1951, so these capacitors here, I wouldn't think are from 51. And I'm not even sure these capacitors here are from 51. There's an old wax one there, and that's what I would have expected to be through the radio. To get it apart, there's some screws here, so I'll undo them and we'll have a look underneath. Okay, the screws are out. Let's take it out and see what it looks like. Well, there it looks pretty good. There's the tube complement. It's a 6X5, an EL33, it's either a 6G8G or a 6B8G, and that's an ECH35. Now just looking at that tube, it doesn't look like an EL33, it looks more like a 6V6. So I'll have a look at that in a second. The speaker looks in pretty good nick. I think it's got a little bit of a crack there. It's probably quite weak. Should be alright though, we should be able to fix that. There's a little bit of rubber wiring in this radio, which I'll have to check. That's just running over from one of the dial lamps to the other, and that's perished there. One's plastic and one's rubber, so I don't know what they've done there. And the lead-up wires to it are plastic. So must have just used what was lying around. So other than that, looks pretty good. Just quickly have a look at this valve. I think it's a 6V6. I'm sure it's a 6V6. A bit hard to see. It's a 6V6. I checked the transformer. It seems to be okay. There's no shorts in it. So I'm going to power it up. I've got my isolation transformer on, of course, and I've got the variac set at about 230 volts. Let's put it on dim bulb and we'll see what happens. That looks pretty good. There's 14 watts there. The bulb's virtually gone out. Recovered to about 183 volts. So it should be enough, and there it started conducting. The globe's coming back up again. I'm not hearing a cracker. I think that's tone. No, there's nothing. I can see the filaments in there, those three. That one I can't see. We're still only pulling 14 watts. I'll put it to full power for a second and see what happens. 25, 27. You would think the wattage would be higher than that. You'd think somewhere in the 30s. I can see a glow in that tube now. Okay, I'll turn it off. What I normally do is measure the plate voltage on the output valve as a matter of course, just to make sure that that's getting there at least. I didn't do that, I forgot. So I'll set that up. Okay, I've connected the multimeter to the plate of the output valve. Here's the power supply. B plus is coming up here into the output transformer. I've connected right in here, which is the plate. That's the output. In this case, a 6V6. So I've connected right on there. And I don't know what the voltage will be, but it'll be something. There's no voltages on this schematic. So there's the that should be the B plus coming up from the power supply, and that should be going off to the top of the plate, the blue wire. So I'll put it on the blue wire. That's assuming it's wired correctly. And let's hit it again. Alright, we'll go to full power. Let's see what we got. It started conducting, the wattage is going up, so it's pulling the 28 watts there. But that's got nothing on it, so it would assume that output transformer's not working. I'll just swap the wires, see if it's going in. It's going in, not coming out. Okay, well that means that transformer's open. Just to recap on what's happening, the power supply here, B+ comes along here, comes up to this transformer. That's the output transformer on the back of the speaker we just looked at. That's the red wire, that's the blue wire. We got about 222 volts there, I think I read, and we've got nothing on that side, so that transformer is open. That's the transformer for the speaker, and there's the speaker there. But we also need to check this valve because something may have overloaded that, so we need to check all these, this valve, the coupling capacitor here, make sure everything's all right in that area and it's not going to destroy our new one. I'll get a new one and we'll shove that in and see what it does. I need to find a replacement transformer to fit in here, and it needs to be roughly the same size so that I can mount it back on its original mounts and make it look fairly original. I've made a spreadsheet that'll help me choose an output transformer to suit the speaker and the output valve that we have. Now the output valve requires a certain load on it, and that's generated by the output transformer and the speaker as a combination. In the little chart here I've written some speakers in, and there's our 6v6 listed there. So if I push the 5000 up there, that's the load that speaker requires on the plate. And it's put 5000 in over here on the left hand cell. Our speaker is a 3.7 ohms. And that tells us we need a winding ratio of 36.8. I can type 36.8 in that square there. And there it goes back to the 5000 ohm. So the transformer is going to need a primary winding of 36.8 turns to 1 in the secondary. All I need to do now is find a transformer that's around about 36.8, and then we can come back to the spreadsheet and put in here the primary winding, how much we actually end up with, and that'll tell us how close we are to our target 5000. I've got a number of possible candidates for transplant here, so I'll have to test them to see if they're going to work or not. I've also got a brand new universal transformer if none of these will fit. That's a bit chunkier than these, I'd rather not use it. I've set everything up, I've got the variac here. So I've set this up the same way as the spreadsheet shows it. There's the output from the variac coming into this meter here, the analog. The analog meter goes into the primary on the output transformer, and the secondary is going onto the digital meter. What we're going to do is adjust the variac till I get 1 volt on this meter here. Then we read this meter here, and that'll be the number of turns, the turns ratio. I'm just going to adjust the variac to get 1 volt on this digital meter. That's good enough. And on this meter we should be able to read this over on 50, so come to 50, there's 20, 30, so it's just a bit over 25 volts. That means that ratio is 25 to 1. 25 to 1. So that's no good. So I'll get rid of this one. That transformer's not working at all. Close enough, 25 on the scale again, a bit less. Alright, that's no good. And that's reading 20, so we're worse off. Getting worse and worse. Yeah, that's nearly 1 to 1. Forget it. The last one. So about 1 volt there, and we got 25 odd again, so they're surprisingly all similar. I have the universal transformer there now, and they give you a little sheet so you can try and match your speaker impedance. The closest I can get is 6 to 7,000. We need 5. We'll try that and see what we get in the ratio anyway, just for fun. And on the meter here it says we've got a turn ratio of about 45. So I reckon if I play around I'll get it somewhere near where I want. I swapped all the connectors around till I got the best result I could get, and I've ended up with about 35 and a half or something. So just going back to the spreadsheet, I had 36.8, that's what we'd like to get. I've ended up with 35.5, So I'll type that in. So we've ended up with a load of 4663, too far off 5000 I guess. That'll have to do, we can't do any better than that. So I'll start replacing that, and that should get the radio working again if there's no other faults. I'm just going to remove the speaker. It's only got 2 screws in it and 2 nuts on the back, so won't take a second. Now oddly it's got a screw on one side and a rivet on the other, so I don't know what's happened there. It's not grounded, the case isn't grounded. So anyway, another thing is I should have undone that before I before I did the screws. Anyway, I got it out. I'll just go outside the workshop and draw that rivet out. I'll be back in a sec. Now I suspect these are the open circuit. I'll just test it while it's out, just to make sure I haven't made any mistakes. And it's opened. Here's our replacement transformer. It's not going to be a direct swap. It's just too big. I can make it fit. That's not a big deal. Now I've got a bit of work to do. I've got to try and get that to fit onto the speaker. I have to repair the cone in the speaker. So I thought what I'll do is I'll just try it out and see how we're going with the radio. So I've just temporarily wired it with some clips, and I've soldered some wire onto the speaker. I've tested the 6v6 valve just to make sure it's not shorted, and it's tested fine. It's not the strongest valve, but it's tested okay. There's no shorts. I can't see any other problems. I haven't done the isolation capacitor. We'll just see what we get, and I won't run it too long. We'll make sure that everything's okay after I test it out. Now I've put a meter on the plate of the output valve to see if it's getting voltage now. I got it on dim bulb. We'll see what it does. And the bulb's gone out, which is good. And we're getting a voltage on our DC meter. It should actually work even on dim bulb now, if it's going to work. There's some speaker noise. Can't hear anything else though. Oh, hang on, there we go. So that's just on 4KQ there, and we go to QR, shouldn't be any music there.
Yeah, yeah. It's set in the 60s or so, something like that. Yeah.
So the one song that's added is in the present.
Okay, that's at full volume, so something's not right still.
It was written so many years ago.
Oh, it's only on. Sorry, we're only on dim bulb. Hang on. Let's put it all the way up.
And such a beautiful song.
Oh,
and,
no, that's working fine.
But there are so many beautiful songs. I mean,
that's what makes it so popular.
And did you indeed have your son confirmed?
And yes.
A little bit late though. It's the start now, Globe Derby, so.
Of the show.
What they'll get is they'll become jealous.
All right. Well, I think that's working okay for me to continue. So what I will do, I'll just shut that off. What I will do is repair the speaker, mount that transformer. I'm still on the lookout for one that's a better suit. These universal transformers are pretty expensive, relatively expensive. I can't remember what they are, but they're sort of $30 or something, $20 or $30. So, you know, a lot of money to put into a $40 radio. I'll do it if I have to. I'm just going to have another look through my stock and just see if I can find something better. Something that would fit would be good too. So I've got loads of speakers and none of them with transformers mounted on them. I found another transformer and I've put that on. This one's very chunky, but these ones are cheap and it had slightly better specs than the other one, so it's a bit more suitable. So I've put that on. It looks ridiculous, but when it's in the radio you can only see the back of it anyway. So We'll have to live with it. I haven't got anything better, unfortunately. It's not ideal. Alright, now the speaker's sorted, I'm going to work on the rest of the chassis. I'm not going to do a whole lot to it, but I do need to clean it up. This dial glass needs to be cleaned, and I'll just use water on that. So I use water and a tissue. I'll give this a spray, I think, because it's got different colours. May not come up so much on the camera, but it's very dark down here and it's very light in the middle. So I'll just spray it, and that comes up pretty well. I'm going to remove the front fascia here, and there's just 3 screws that'll come off. I'll have to take the string off, but that's such a simple dial string, and it's not going to take a minute. I need to change the rubber on the capacitor here, the tuning capacitor. There's, I think there's about 3 or 4 rubbers. I'll just replace them with just grommets, and I'll try and just clean up the chassis somehow. Perhaps clean this up. That's all rusty in there. Might try and do something with that. Just make it look a bit more presentable. And I'll put it all back together with the speaker in it. We'll flip it over, and then I can check all the components, make sure voltages and the tuning's okay. I think it's pretty good, actually. So we'll check it all again anyway and make sure. So I think the first thing to do, take this fascia plate off. I have to do something with these rubber mounts for the capacitor here, the tuning capacitor. So I've got some grommets. I'm going to take these out and put grommets in. So I'm just going to remove the screws here, the nuts. Well, there's the 3 nuts and bolts out. The rubber is so hard, it's gone very hard. Now I've got some new grommets here, but they've got a large hole. I guess the original grommets had a much smaller hole to accommodate the smaller screw. So what I've done is I'll fit these. Now I've got a small grommet, and that fits nicely in that hole there. So I'll put the small grommet inside around the screw, and when I do it up, it'll form into a quite a rigid grommet assembly. I'll just tighten up all the screws, and they're not too tight, just doing them up gently. So that's good. The capacitor's firm, but it's just got a little bit of give in it to absorb the shocks or whatever. I'm not sure what they're for, actually. Well, I can put the front fascia back on again. I've remounted the speaker already. That might be a bit easier. Now it's got to put the dial string back together. Now, who remembers how this went? I think that would go up there. Around there twice. Oh, that doesn't look right, does it? That's not right. Okay, I went around there twice. Once. Twice. Around there, drop that in there. And there. Oops, what was that? Broke the end off. Okay. I think that screw does up when that's right at the top, because there's little marks on the shaft. I think it's about there. I've got the tuning capacitor fully meshed. Yeah, it's probably close. That's a replacement string, so someone's been in here not that long ago, because that string's very new. I have to go and fix that little bit of tin that's come off there. I'll just solder another bit behind it or something. I need to connect these two wires together. It's for the new transformer going down to the wire down to the plate on the output valve. What I've been doing lately is using Quigs. Quigs was a product of Sprague in America, and what they were little coils of wire that are pre-tinned and fluxed, and you slip them over a wire and solder them together. You can't get them anymore, but I've been rolling my own and just using this little tool here, and these work really well. Now a lot of times if I'm just changing a component, I'll just wire it straight onto the lead of the component, but that's just some 22 gauge tinned copper wire, and that's it. Just roll it into a spiral, cut it off. There's little tabs at ends there. You either bend it out or cut it off, whatever you prefer. So now I've tinned both bits of wire, and it's just a matter of putting the quig in the middle there, like that. And mine aren't pre-tinned, mine aren't pre-soldered, so I'm going to just solder them myself. There it is. Beautiful. No twisting, no nothing. Well, no twisting of wires anyway. I'll just put a bit of heat shrink over the top. This heat shrink's a bit small, but I'm getting there, so it'll be alright. Alright. And just shrink it on. I'll do the other one behind it there. And there it is. That's very neat, and quite a strong join as well. So I put a bit of plastic around those wires, and there you go. I was able to test 2 valves in my normal valve tester, but I've got 2 in this radio that aren't listed, so I'm going to try it in my new tester. And this one's very complex, but it's probably very thorough. I think this was made in the 50s by Pellick in Sydney. So I've only just recently got this, and I've only used it a few times, but it's a very complex way of testing valves, you ask me. Anyway, I want to test my ECH35, and I haven't been able to do that up until now, so it goes in that slot there. I've put a clip lead on there because the little clip on the lead is so rusty, I don't think it'll make contact. These things are called function levers, and there's 10 of them, so you've got to set them to do various tests on the same valve. So it's, as I said, I can't remember how to do it. I have to keep looking it up. So here's the list of function switches and their positions during test. So there's our ECH35, there's an F1 with an asterisk, and there's an F2 and an E. There's the voltages and range settings. The first test is the filament continuity. So you push it to shorts, push F2 down to 7, number 2 goes to E, and if we get a light, we're okay, the filament's okay. Now to check for shorts in the elements, we put that to F1, and all the other ones go to E, so it's that one except number 5. Just that one, we'll leave that there. I don't think you do 8. Yes you do. And 8. So that's showing those shorts. If there was a short, the light would come on. So now we put all these levers back to F1, or put them down to F1, like that. That one goes to F1. I've set all these switches in the right position for the first test. This is a 2 tester on this valve. I've got the merit number 3. I've got this set to about 24. So we should be able to just turn it on, and it'll slowly come up to show us where our valve is. So it's still showing that it's reasonable. I've got to say, any valve I've tested in this has never come up much higher than that anyway. So I've just got to rearrange these switches again for the next test. Alright, I'm all set for the next test. I've got to put that on 26, I believe. Alright, let's see what this one does. That's a good deal better, isn't it? Well, I think that valve's alright. Bit hard to say with a crazy test like that. So I'll do the other one. This is a 6G8. But I've done all the shorts and element test and filament test on this. I'm not going to bore you again with that. And I've set all the switches as per the chart. Alright, I'm all set here. Let's see how this one works. Oh, that's very good. Alright, just give me a second. I'll reset this to the second test. Okay, I've set the levers and the dial to the second test positions. Let's see. So it would indicate that part of the valve's not working very well. I haven't got any more of these. So this is a double diode pentode valve, so perhaps it's the diode section that's not working so well and the pentode is working. Possibly it doesn't like testing diodes in this meter, I don't know. Seems odd to be so far down on the diodes. We'll see how it performs in the radio. I've reworked this dial pointer so the string should stay there now. Now there's a mark on the glass where the set pointer is, and I've got the tuner fully meshed now, so I'm just going to mark the string where I want it to end up. So I'll wind it back here, otherwise I can't do it right at the end there, it's just going to be too difficult. So I'll just take the string off for a second. And that should go in there like that. There we go. Should be able to get that over there like that. There we go. Good. That was easy. I'll just see if it works. Yeah, it's a little bit out and might even be a bit bent. But I'll straighten that up. I'll put a little square on there, make sure that's running square. When I put the glass on, I'll probably need to adjust the position of this pointer. I'm not going to change the string position because it's too hard. So all I'll do is just undo the screw here and I can just adjust the wheel here. I can put the glass on now. So I've repaired the wire here that had some rubber wire in there. And the glass is held on with clips which also double as lamp holders. So that will go under there. So the glass will fit in there like that, I hope, and these should just go on. Alright, that looks good. Now I've just put some tape down here. It used to have rubber on it, but I haven't got a thin enough rubber, so this tape works pretty well. Now I haven't finished cleaning the outside. I've cleaned the bottom of the glass quite well. This outside still needs to be cleaned up properly. It's got still got grime around the bottom there and around here, so I'll fix that up later. When I go to align it, that point is supposed to line up with that set point, and we're just a bit short of it on there. So I'll just adjust it. As I said, I can use this screw now to adjust it, and from my angle that's spot on actually. I also put a little square in there and checked that needle was straight, and I had to bend it around a bit, so I know that's perfectly straight now. I've done this differently to what I normally do. I normally get it all working, then pull it apart and clean it. I've cleaned it and now I've got to get it working. So before I flip it over, I'm just going to make sure it actually still works after I did pull it apart a little bit, not too much. I'll just make sure it is still working. I haven't put the globes in. It's a bit of a distraction when they're on with the cameras and everything, so I'll leave them out till last. But there's some noise there. Hang on. That's on shortwave, I think. Oh.
Write a song or go, I think I'm going to put some words down and have a go at this.
So I've actually got it on shortwave and I picked up New Zealand.
Recorder. We used to write our own little ditties and just basically, put the sellotape back on the cassette and then sing our own things and then wipe it again.
Ah, there you go. How about that? Didn't know New Zealand had shortwave. I'll see if it works locally.
That's my role.
There we go.
session.
It's working, so, but I just noticed the pointer's on this side of the 4KQ now. It used to be on the other side, so I've got the pointer in a different place of what it used to be. It's quite a bit off, and I'm pretty sure we're on 0. Yeah, so we're on the set point. So it's going to need a bit of adjustment there. That was interesting getting New Zealand. I didn't know they had shortwave. Not that I've ever done much with shortwave.
It's powerful in her vocal stylings. The rhythm, the intro itself is really compelling. You know, it's got this great rhythm thing that captures us everywhere. But then she's got her vocal stylings.
I think it's rough listening to an Aussie. Boy, you want to listen to some New Zealanders? I'm kidding.
有足老爺最開心嘅，要有最簡單嘅老爺我愛你。
I don't know where that would be. It's Asian of something, I don't know what. Sometimes we can get Nauru. Anyway, that's enough playing around. So I think as far as the top's concerned, it's all done. It's reasonably clean, looks a bit better. Took a bit of the rust off the chassis there, that's okay. I think I'm going to need to flip it over so I can check all the bottom out. And but I don't know, there's no way of flipping it upside down. So I'm thinking maybe I can get some bits of timber and just screw them temporarily on the side there so I can turn it upside down safely without fear of damaging the glass. I don't want to do that. Now you probably would have noticed I've neatly put the tape all the way down the glass there. I'm going to have to cut that off because the globe's supposed to go in here and shine into the side of the glass. So I'll cut that off and do it properly. I don't know what I was thinking there. Anyway, I mounted the radio upside down in a couple of boards like I said, and that seems pretty good, so I can work on it now. I said before I didn't have any voltages. Well, I found this schematic, which is the same valve lineup as mine. It's out of about 1948, I believe. But it has the voltages on it. So I can use these voltages. It says here the cathode's 16 volts positive, so I don't quite know how that works. Hang on. Here's a clearer schematic, but there's the cathode there and it's going straight to ground. So what I assume it means is the grid is 16 volts below the cathode. Now it also says, this is the valve specs for 6V6, it says the grid voltage should be about minus 8.5 at 180 plate voltage, or 250 should be 12.5, so nowhere near 16. I haven't measured the plate voltage, but I think it's somewhere near 200, so that should be about minus 9. What I'm interested in is this coupling capacitor here, C27. That blocks the DC from this side of the circuit, which is, I think, somewhere over 100 volts there. So that blocks that from getting onto our grid and just lets the audio signal through. Now, because that transformer was blown, I need to check that to make sure it's not hasn't got DC getting on there and upsetting the valve and causing it to pull too much current through the plate and blow that transformer out. Now, if I measure here, which is just after that coupling capacitor, we should have 9 volts or so, and we've got about 3. But seeing that so high, I'm going to take that capacitor out and replace it. There's a new capacitor. I've replaced that old one. We'll see if that's made any difference. I bet it hasn't. So we're still on about 3 volts there, so that's done nothing, and I kind of didn't think it would. Just so we know what's going on, the grid up here needs a lower voltage than the cathode here, and that cathode's going straight to ground. This is my take on how this centre tap and the bias is developed. All the current comes back through here to go to the centre tap. So these resistors have a voltage drop across them, and that gives you a negative compared to ground up here. And that's what the bias is, it's a negative voltage on this grid here. Now there's no voltage drop across these two resistors because there's no real current flow there. So this is pretty much just a blocker to stop the signal wandering off down there. I think that's a grid stopper to try and get rid of any stray signals that might end up in there. So the voltage drop is across these two resistors. Assuming these resistors are right, and I can check those, is this capacitor here. Now this capacitor here comes off the cathode. It's an electrolytic, and it joins that high voltage there, which is in the 200 range, onto our centre tap wire there. So maybe that's got a minor leak. I haven't changed that. I normally change those just because they're old. I haven't changed this one, so that's a possibility. I'm kind of floundering here because I really don't know how radios work. I'm just making this up as I go along. So I guess the thing to check is these resistors and change that cap. I can't really check it for leakage, so I can only change it. So there it is there, off the cathode, goes onto a spare pin here, and then there's two of the resistors we were talking about before. So the new cap's in. I just used a 16 microfarad as was in there. There's no hum issues, so I think that'll be okay. I've just put the radio on, and I don't expect any difference.
We are, how hard we work off the field.
Now that's actually showing less than it was before, so I don't know what you'd do. Now I've been a bit silly with this. I've concentrated on an area that's got an issue and not checked out the rest of the radio, and that's not how I should do it. And I'm not sure why I got on that track. I really just wanted to change that capacitor, because that may have caused the issue with the output transformer. I should have just changed that and stopped there. As it turns out, that capacitor was okay anyway. So I'm just going to check some resistors while I'm here. The capacitors have been changed previously, and I will assume at this point that they're okay. I will change that old wax cap there. I don't know why they were left that. It's not an area that's going to make a lot of difference, I guess. So I'm going to check some resistances and see how they come up. So that's orange, black. So that's 3, 0 and 3 zeros. So that's 30. And we've got 40. Okay. That's another 30. That's 46. So what's that? 25% over. This one's brown, black and green. So that's 1, 0 and 4. That's meg. So 5, I'm sorry. So that should be 10. Or 1 megabyte. Yeah, 1 meg. It's not too bad. 1 meg. That's 12. Yeah. This looks like brown, green and orange. So that's 1, 5 and 3 zeros. So what have we got? 15 it should be, so it's 19, so that's a bit out too. I don't think any of those are going to make any difference to the operation. This one's green, black and yellow, so that's 5, 0 and 4. So that's, oh, hang on. It's open circuit. It's not even that, is it? Oh no, we got something. Right on. No, 19. As I started to say, that's green. Might be black on the end there actually. So green, black and yellow is 5, 0 and 4 zeros. So it should be half a meg, 500k. And it's reading 19. Now it's reading nothing. So I'm not sure what's going on there. It might be reading low because it's got another path for the resistance to go. So, but it's certainly something wrong with it there. Well, at that point I've got some that are 25% over. That one's got some issue with being intermittent or something wacky going on there. I'll cut that out and see what it's doing. These ones I can't read. I'll have to try and get it out of the circuit diagram. Anyway, I'll fix some of those resistors, certainly that one, and see if that starts to fix some of our other problems. I tested all the resistors now, even these ones here that I can't read the numbers on, so I use the schematic. I've changed these guys and these two guys, and I also changed a capacitor that was here. It just had some cracks in the top, so I thought I'll just get rid of it. I also changed the waxy cap that was sitting in here. Get that out of there. So this is the one that was showing open circuit, and if you just move it around a chain, you can select whatever resistance you like, really. So let's power it up. I've got it on dim bulb just in case I've cross-wired something, and everything's normal. So I go full power.
Someone who's last 3 years in the gym, it's incredible his body shape and how much it's changed. But he's tied with an admin going down the 18, so that's one to watch.
Well, something just went pop then. And we've got a lot of hum in here, so and it's coming through from the filters. Well, nothing's happened since. There's no smoke. I'm just looking and I can't see if I can't see a mistake that I've made in the wiring, but there was a definite little electrical pop, and as I say, it's now got quite a bit of hum in it, and the volume's down, so it's in the it's past the amplifier stage. So hum generally will be one of the capacitors. Now I've changed that one. This is the old one. What I've got is a couple of clip leads and a 16 microfarad capacitor, and I'm just going to go across there. I don't think it's shorted because there'll be a whole different set of symptoms. So black's negative, so I'll just put that up there. And put the red one on there, the positive. Now I'll put it on before I start. I don't really want to put the capacitor in the circuit, an empty capacitor, while the circuit's charged, so it'll just rush. So I'll wire it in and see if the noise is gone.
More watchful next delivery.
Yeah, that's perfect. So let's see what happens if I take this clip off. There's the hum. Gone. Hum. Yeah. So it's that capacitor, so it's become incapacitated, I guess. I'll take it out, put a new one in there, and we're back where we were a while ago. Yeah, I'll put the new one in there. Here's the old one. It's 16 microfarad and it's reading 0. So it's just gone open circuit inside there somehow. So that was the little tick I heard when we started it up, and that just went. So it doesn't matter how bright and shiny they are, you don't know what they're like inside. I've got it powered on. I'm just going to check that bias again, the grid bias. And we're nearly at 8 volts now. So that's come up quite considerably. Got up to 8, and that's around about what the valve requires. We've got a plate. Where's the plate? The plate is here, and we're 191. We've got about -8 volts on the grid bias, so that's just slightly less than what the specifications say, but it's well less than what the schematic says for this set. But the resistors that are in there for the grid bias are still manufacturer's resistors. They've still got the little painted mark on the solders, so I'm reluctant to start redesigning the set. What I can do is work out what the maximum plate dissipation is, and just make sure it's not going to be it'll be low if it's going to be anything. There's no distortion in the sound. The sound's clear, and so I don't think we're going into the regions of the valve we're not supposed to be going to. But what we can do, we can measure the current draw on the plate, and I'll do that by just clipping that on there, and I'm just going across that transformer, the output transformer's primary, and we've got about 6 volts. That's not much, is it? I would have thought it'd be 15. That's really not a very good output transformer. I probably shouldn't be using it, actually. In fact, I won't get any more of those. As I said, the one I really should be using, they're $43 I looked today. So a lot of money to put into a set that's going to sit on a shelf. So I've got the voltage drop there. I'll turn the set off. I've changed my meter to resistance. Now I'll just check the resistance of that primary, and it says 220 ohms. We can use Ohm's law to calculate the current draw through that transformer. I equals VR for this purpose. So so the voltage was 6 volts, and we divide that by 0.220. That's the resistance in K, and that equals 27.27 milliamps. So what I've done, I've actually desoldered the transformer from its little point there on the valve, and I've put my multimeter in there just to see what it comes up to, and it's 27 volts. So I've got the leads backwards, but it's 27 volts. 27.27 doing the calculation, and 27.14 on the meter. So that's pretty good. So if we multiply that by the plate voltage, which was 191 volts, and then we divide by 1000 to bring it over to the right thing, yeah, we get 5.2 watts. And the maximum plate dissipation on this 626 is 12 watts. So it's well within its operating range. In fact, it's almost idling. As I said, I don't really feel like starting to play around with to get it somewhere higher than that. I could change the resistors, and but I don't think it's worth it. I don't think it's worth the effort. I don't think it's going to improve it enough to be worried about. Now, I went through, while I was doing all these resistors and everything, the capacitors, I tested all the other capacitors. I did all the voltages as well, and everything's really good, actually. it's all a little bit low, but it's okay. I wouldn't. I'm not going to worry about it. So I think I'm happy to go over and do the alignment now. It's time to check the alignment. So I've got the radio on. Now I've got an AC meter connected via a capacitor to the plate on the output tube. So that'll give us a voltage reading, and we need to maximise the voltage reading on that. There's the two IF cans from the bottom, and then there's two adjustments on the top as well. So I can do that. I'm going to do it upside down at this stage. Now I can just use a normal screwdriver because they're just screws going in there, so it shouldn't make too much effect. These have never been adjusted. But before I do, I'll just see where we are with it. I've got the volume on the radio maximum. The RF signal coming out of the generator is on minimum at the moment, and I'll just turn it up. So I've got the generator at 455 at the moment. Keep your eye on the meter. I'm just going to sweep back and forth. We'll see what it comes up with the maximum voltage on that meter is. Look at that. I reckon spot on. What do we got? 455. So there's absolutely no need for me to adjust that. I'm completely happy that that's the best it'll ever be, and it's never been adjusted. Next thing I've got to check is the tuner and the oscillators, and just make sure they line up with the stations on the dial, really. So I'll do that. I'll have to work it out. I don't have any instructions for this, so I'm going to have to wing it. I think I've worked it out. That's the broadcast band antenna coil. I think that's the shortwave coil. That's the oscillator for the broadcast band, and that's the oscillator for the shortwave band. So there's an adjuster in there. It's a big black slug. I think you can see that. There's also a screw here on the oscillator, and there's some little tuning capacitors up here for the top end of the tuning. I'll set the oscillator to 600, and we'll go up and we'll adjust which one of these capacitors is the one that for the oscillator. I'll turn the radio on. I'll set the frequency meter to 600. Now I've got a camera around the back here, and it's got a bit of reflection on it. We'll see how we go with it. I've put the set point on, and we just check the set point, and that's spot on. Now I need to go back to 600, which is here. I think that's about right. Now I've turned the generator up. We should get a signal. We're not getting much though. Just see where it is. Yeah, it's pretty much what I thought. So I'll set it back on 600, which is about there. So to bring that back, I'm just going to adjust the oscillator. There's a little lock nut on there. I'll get that off. That's okay. Correct. This should adjust that. Whoa. Oh no, broke off. Well, that just broke off the little screw head, so that's made a mess of it, hasn't it? So now we go for the rough stuff. We'll see what we can do. So just keep an eye on the meter there. I've managed to move this. I don't like what I'm doing. That seems to be about it. So I'll scoot up the other end of the dial. We'll go to 1400. So that's pretty close to 14. So now I've got to set the meter to 14, the generator. So that's come in pretty good there. Actually, that's pretty much spot on. So if I'm right, this little trimmer here should adjust that oscillator. Alright, so I haven't really adjusted that. I did move it, but I just put it back where it was pretty much. So I don't need to check the bottom end again. All I do need to do is peak the antenna trimmer until get maximum signal from that. Now I've just got to adjust the trimmer for the antenna, and that's it there. So we're on 14 still, and I'll just peak that. And that's it for that. I'll just go back to 600 and I'll peak that slug there. So I've tuned in 600 again on the dial, and I've got 600 on the generator. So if I can get in there on that slug, and I'll just turn the radio volume all the way up again. And we just maximise the signal here. And that's about as far as it's going to go, so I'm going to leave it there. That's the broadcast band adjusted, and that should be aligned pretty much spot on. I do have to tighten the nut on here. Okay, that's done up. I'll just check that it hasn't moved any. No. Still on 600, that's good. I apologise for having used graunching tools on that thread. If I could have got it out, I would have, but I think you'd have to screw it all the way through and come out here, which means taking the coil out. So now the only other thing to do is the shortwave, and I'm not terribly worried about it. What I normally do, and I haven't done a lot of shortwave, and I have got no instructions on how to do shortwave. All I've done previously is to set the generator on about 12 or 13 or so. So I'll set my generator on 12 megacycles, which is there. I think I'm right over the top of there. And set the radio on 12, where are we? Set the radio on 12, and there's 12 there, and see if we're on the signal. There it is. I'm happy to leave it there. It's no good me adjusting it if I don't quite know what I'm doing with it. One day I'll get some instructions on how to do it, and then I'll be able to do one properly. The only thing that's outstanding now is the case, and the case is in good condition, so I'll probably just go out in the workshop, polish it up, bring it in, and we'll put this back and see how it looks when it's in. There's the case all done. That came up pretty well. Took next to no time to get that sorted. Now I tried to clean the grime that was on here, and it just would not come off. So I ended up using some steel wool, very, very fine steel wool, and some lens cleaning solution, and that's finally got it off. So it was almost like fly dirt or something that just would not come off. So that's looking good now. I think I can pop it back in the case. That's gone in nicely, so I'll just put the screws back. Just put the bottom screw in and flip it over. Now I've got some new felts to put on. These ones are black. I would have preferred brown. I'll get on to Carl. And his links in the description. He now has felts, so I'll get some brown ones. I've just run out at the moment, and the knobs go back on. I've cleaned them up. There it is, all done. A Kriesler plum pudding from about 48, 49. I found an old print advertisement for one of these, and Kriesler called it a Midget. In the first part of this video I wondered if they still called it a triple throat. The advertisement says it is a triple throat, so that has an outlet there for the speaker and two at the back. So this divider qualified it as a triple throat. I think that's a bit of a cheat, but anyway. I'm very happy with this radio. It looks really nice, and it's come up alright. And it sounds quite good considering the size of the speaker. It's quite good.
They've risen in cost by over $24 billion since first announced.
This is my last video for 2019, and thank you very much for watching, and I hope you enjoyed this one, and I wish you and your family all the very best for 2020. Thank you for the comments that I get. I enjoy reading them. Most of them are good. There's a couple there that are critical, and I take that on board, and I try to improve what I'm doing. So in early 2020, keep a lookout for my next radio adventure.
On an international flight from Sydney have been given hefty jail sentences. Details from Jamie McKinnell. Khaled and Mahmoud Kayat were found guilty of planning to bring down an Etihad Airways flight with a device